Hello my dear students, welcome back to the physics classes. Our next topic is principle of moments. In the previous topic we got to know about the kinds of equilibrium. There we have studied two kinds of equilibrium. One was static equilibrium and second one was dynamic equilibrium. So in this case of equilibrium, you have got that the forces were acting in the opposite direction and they were zero if the body is maintaining its state of rest. Also, if the body is in motion, like in case of aeroplane which was flying and at the particular height it was maintaining its state of motion, then in that case the algebraic sum of moments is also equals to 0. That means in every case the sum of clockwise movement, that if you take plus, and anti-clockwise movement that you take minus, will always be coming 0. Or you can say that sum of clockwise movement will be equals to the sum of anti-clockwise movement. So basically this is your principle of moments. What this principle of moments is? According to the principle of moments in equilibrium, the sum of clockwise moments is equals to the sum of anti-clockwise moment. Let us understand it with the help of an example. Suppose you have you are given a rod which is tied at a point, which is pivoted at this point. Okay, one force F1 is applied here, other force F2 is applied there, another force F3 is applied there, and another force F4 is applied there. Several forces are acting in this rod. Their distances, this distance from the pivot, if you assume it O, so from F1 the distance is R1, from F2 the distance is R2, from F3 the distance is R3, and from F4 the distance is R4. So what does this principle of moment says? It says that sum of clockwise moment, just consider this force F1. When this force is applied, the rod is going to rotate in this manner. That is your clockwise moment. So your clockwise moment will be F1 multiplied the distance from the pivot, that is the R1. This distance is your R1. So F1 multiplied to R1. Okay, then check, is there any more clockwise moment? This force is going to rotate the body in anti-clockwise manner. F2 is going to rotate the body in anti-clockwise manner. This F3 is going to rotate the body in clockwise manner. So what you can do, you have to write here plus F3 into R3, that is force F3 multiplied by distance R3. Then check is whether this force F4 is rotating this in clockwise direction or anti-clockwise direction. This F4 is going to rotate in anti-clockwise direction. So this F1R1, that is sum of clockwise moment, is going to be equals to sum of anti-clockwise moment. Which one is anti-clockwise moment? F2 into R2. F2 into R2 plus this F4 into R4. This is basically said by the principle of moment. If several forces are acting on a body and which is able to rotate, so in case of equilibrium, that is in dynamic equilibrium, the sum of clockwise moment will always be equals to sum of anti-clockwise moments. Now if this principle is given, there is its proof as well. So let us understand its proof, that is verification of principle of moments. For that you need to take a strong thread. Just tie this strong thread with the help of a rigid support. Okay, now one end is fixed with the rigid support, the other end you need to fix it on a uniform scale of uniform length and mass. Suppose this is the scale. Okay, now you have to tie this scale at its center. At the center of the scale you have to tie by other end of the thread. The thread has got two ends. One end is fixed on the fixed support and other end is tied with the scale, and the scale is tied at the center. What is your next step? Hang there two different spring balances. Hang on both the side two different spring balances. Suppose you have hanged here one spring balance and you have hand there another spring balance. Now what is your next step? Just tie their slotted weights, and there also tie slotted weights. Suppose this weight is your W1 and this weight is your W2. This distance of W1 from the point of pivot or fixed point, that is your L1, and this distance, that is your L2. Now I am assuming that W2 is greater than W1. What will happen? This bar or meter ruler will tend to move in the downward direction. Now here what you have to do? Either you shift this spring balance in that direction, or you will have to shift this spring balance in that direction. Understood? What will happen if this side is going downward? That means you need to shift that spring balance in this direction. Then you will find that at after some time, when you will keep on shifting, this scale will be in the horizontal position, and state of equilibrium will be achieved, and state of equilibrium will be achieved when the scale has come in the horizontal level. That means it has stopped showing any kind of motion. Now in that case what will happen? The W1 will try to rotate the scale in anti-clockwise manner. The W2 weight is trying to rotate the scale in clockwise manner, right? Let's understand, let's find its moment. Moment of force W1. What will be the moment? W1 into the distance of W1 from the point of pivot, that is L1. Again, moment of force W2. That is going to be force W2 multiplied by the distance, that is L2, from the point of pivot to the force, line of action of force, that is your L2. Now, if the body is in state of equilibrium, when the body is in state of dynamic equilibrium or static equilibrium, I am writing here only equilibrium, state of equilibrium, then what will happen? This scale is not moving at all. So one is in rotating the scale in clockwise manner, other one is rotating in anti-clockwise manner. If you take anti-clockwise manner as positive, so clockwise manner will be negative. So this moment of force W1, that is in anti-clockwise manner, this became positive, and this clockwise manner became negative. Now their algebraic sum, W1 into L1 minus W2 into L2, will be equals to 0. Why 0? Because the scale is not showing any kind of motion. So when the scale is not showing any kind of motion, you have got here W1 L1 equals to W2 L2, and this is basically what? Sum of anti-clockwise moment, and this is equals to sum of clockwise moments. Here we have used only one force, that is W1, and there that is W2. So you can remove this word sum of, but if you put so many forces, so many weights on this side and this side, so once again you will find that the sum of anti-clockwise moment will come equals to the sum of clockwise moments. So this is basically the concept of principle of moments, and that is the verification of principle of moments. If you have any confusion, you can mention in the comment section and your queries will be resolved. Thank you, children.